everyone. Today we will explain about chapter 1, and which is 1.3 of extremum of functions of two variables. At the end of this topic, we have to able to determine the stationary point by solving simultaneous equation up to third degree polynomials. The second thing is to determine the nature of stationary point AB by using the second order partial derivative test. And the second thing we have to know in this topic to solve problems related to economics and business. Local extrema is all local maximums and minimums on the function's graph, and it occurs at critical points of the function where the derivative is zero or undefined. The term of critical point may be confused with the stationary point. Critical point is more general. A critical point is either a stationary point or a point where the derivative is not defined. Thus, a stationary point is always a critical point, but a critical point is not always a stationary point. It might also be non-differentiable points.
We will start next. We will discuss the tutorial.
Okay, so we will discuss the tutorial 1.3. So the first question is find the stationary point of the function fxy x y minus x power of 2 minus y power of 2 minus 2x minus 2y plus 4. So when they ask for stationary point, so we need to find the fx and also the fy. First, we list out all the x that has in the equation. So as we can see, the x is xy minus x2 minus 2x, and when we want to find the fx, it will be y minus 2x minus 2. So this is the fx. We find the fy. Fy, we has xy, we has y minus 2, y power of 2 and minus 2y. So we will get y minus 2y minus y. Next we find the fy, which is xy minus y power of 2 minus 2y, and we will get x minus 2y minus 2. And then we will choose one of the y or x to be the subject, which we will choose x equal to negative 2y minus 2, and we will get x minus 2y plus 2. So we will get the subject x with 2y plus 2, and we will insert it in this equation. So we will get y equal to 2x plus 2, and when we substitute x into this x, we will get y equal to 2y equal to 2y plus 2, and we will get 4y plus 4 plus 2 and 4y plus 6, which y equal to 6 over 4, 9. And y minus 3y equal to 6, means 4y equal to 6 equal to negative 3y, 6, and y equal to 6 over 3, y equal to negative 2. So we get the answer that y equal to -2. And we will substitute y -2 into this equation. So x equal to 2, -2 plus 2. So we will get the answer is -2. So we know that x is -2 and y is -2. From this we know that the stationary point is -2, -2. Let's find the stationary point of the function f u v. So if this we use f x y because they ask for x y, and this they ask for u v. So we will find the f u v. So we will find f u first and f v. So we list out all the u in this equation, which is u power of 2 plus uv plus minus 3u, and we will get 2u plus v minus 3. And for fv, we will do v plus v2, and we will get u plus 2v. And we will choose one subject, which we will choose this as u equal to -2v. And we will substitute this u equal to -2v in this equation. Make v as a subject first. So we will get v equal to 3 minus 2u, and we will get 3 minus 2, and we will get 2v. So 3 plus 4v is v, and v minus 3v minus 4v equal to 3, negative 3, v equal to 3, and v equal to -1. So we get the value of v is -1, and we will substitute the value of v into this equation. So u minus equal to -2 in bracket, v -1 here, so we'll get 2. So the stationary point which they ask for u and v, so the value of u is 2 and the value of v is -1. That's all.
So next, let us look at the second order partial derivative test. We will get 4 conditions from this test. The first one, we will get the derivative point is greater than 0 and f(x)(x) is less than 0. It means that it is a maximum point. The second one, if we get derivative point is greater than 0 and the f(x)(x) is also greater than 0, it means that it is a minimum point. The third one, if the derivative point is less than 0, we no need to consider the f(x)(x). So we just consider it is a saddle point. The fourth one, if the derivative point is equal to 0, it means that the derivative test is failed. To get the second order partial derivative test, we have 4 steps. The first one, we should find fx and fy to find the value of x and y. The second one, we should find fxx, fyy, and fxy. The next one,
use the formula of fxx multiplied by fyy minus fxy squared to get an equation. And the last one, substitute xy in the equation to find it, whether it's a maximum point, minimum point, or a center point.
Go to the next tutorial, which second order partial derivative test, the derivative test. So first we look to the question which they ask us to find the stationary point and also determine their nature. So the stationary points means you need to do the first order. And their nature means they ask us to do the second order. So their nature means either they are maximum point, minimum point, or saddle point. So we need to do the second order to find their nature. So for the equation, we need to find the fx first and fy to do fxx and fyy. So fx is y minus 2x minus 2 and fy is x minus 2y minus 2. So and then we do as the first order, we do the first order. So I choose 1 to be as a subject. So we choose x as a subject, we use fy, so we will get x equal to 2y plus 2, and we substitute the fx and make y as a subject. So y equal to 2x plus 2, which we know x is 2y plus 2, so we substitute and 2 in bracket 2y plus 2 plus 2, and we will get 4y plus 4 plus 2, and y minus 4y equal to 6, y equal to negative 2. And next is fx. Next is find the x. So our x is x equal to 2y plus 2. X equal to 2y plus 2, and we know y is negative 2, so x equal to 2 in bracket negative 2 plus 2, and we will get the value of x is negative 2. So we know the stationary point is negative 2, negative 2. So we get the first question with stationary point, and next we will find their nature. With their nature we need to do the second order. Second order, we need to find fxx and also fyy. So we know fx is y minus 2x minus 2, and fxx will be negative 2. And fyy, we know fy is x minus 2y minus 2, and the fyy is negative 2. And we need to find the fxy or fyx equal to, so we know that the fyx, or we choose this fyx minus 2y minus 2, and we want to find the fyx, so we'll get we will get 1. And then we need to find the point to know their nature. So the formula for derivative point is D equal to fxx fyy minus fxy power of 2, and we just substitute the value with fxx equal to -2, fyy equal to -2, and the fxy is 1 power of 2, and we will get -2 times -2 equal to 4 minus 1, and we will get 3. So this means they have to value either maximum or minimum point. So we know that if the value is bigger than 0, that means it will be the maximum point, and if it is less than 0, it will be minimum point. So we see that this value is 3, which is bigger than 0. So we know that the nature is maximum point. So from this fxy, we know the stationary point for -2 is maximum point.